Hello, I'm Rob Pitts with New Light Technologies, and I'm going to talk for a few minutes about how open source technologies are driving mission results. This will include a look at several recent implementations of open source that are improving outcomes across large federal programs and international NGOs. The continued growth and advancement of open source software has led to a rich ecosystem of communities and technologies that are enabling organizations to keep up with the pace of change and build really creative solutions to some of our most important national and global challenges. An expanding set of open source libraries and tools are tailored for enabling the development of open science models, spatiotemporal databases, interactive 3D web applications, visualizations, and scalable platforms for sharing maps and geospatial data. Through my work at New Light Technologies, I am involved in a variety of large-scale research, development, and technology modernization projects with different federal agencies and international NGOs, where the use of open source is vital in transforming the way geospatial information is being collected and analyzed and communicated to deliver insights and mission results. For example, at the US Census Bureau, we have worked with the Research and Methodology Directorate to support the production of new socioeconomic data products, including those from the Center for Economic Studies, and the development of analytical tools and dissemination platforms for the public. Here, open source technologies and software is a bedrock of the data engineering lifecycle and a growing suite of interactive web-based applications for accessing and querying and visualizing massive databases to explore the spatial and longitudinal dynamics of the American economy and workforce. The U.S. Army Corps of Engineers provides vital public works, navigation, and military engineering services, including a range of digital geospatial data and tools relied on to support missions across the federal interagency community. This includes development and management of the system for distributed collection, storage, and reporting of geodetic, survey control points, tidal, and water level datums that are part of the National Spatial Reference System. Here, we worked with the Corps to modernize the Survey Monument Archival and Retrieval tool known as USmart from an on-prem technology stack to a new open source, cloud native, and serverless architecture, improving its scalability and performance while reducing maintenance costs and technical debt. The new solution, shown here, leverages modern web frameworks and open source libraries to enable federated authentication, seamless online and offline data collection for field users, and robust mapping, reporting, and 3D visualization features. At FEMA, we've been involved in supporting the Response Geospatial Office design and operationalize predictive analytics and decision support tools for disaster response and recovery operations. This includes development of an analytical framework and web platform for delivering risk assessments in real time. The Tool for Emergency Management Prioritization and Operations, or TEMPO, leverages a scalable cloud-native architecture to ingest best available data detailing the location and intensity of hazards, along with population, infrastructure, and other community information to determine areas and lifelines of highest vulnerability, impact, and cascading effects. Results are disseminated through APIs and a web-based dashboard shown here with flexible tools for searching, filtering, visualizing, and exporting information to support risk and exposure analysis, resource planning, search and rescue operations, data collection, tasking, stability tracking, and essential information for the National Response Coordination Center. Here, open source libraries facilitate a dynamic web visualizations and a highly responsive user experience. As disaster impacts rise worldwide, timely access to information related to the distribution of vulnerable populations and critical infrastructure is key for effective disaster relief. OpenStreetMap has become a vital resource for disaster mapping projects worldwide. However, large portions of the globe, including countries exposed to natural disasters, remain incompletely mapped. To address this, researchers from New Light and the World Bank developed a methodology using remotely sensed measurements to accurately predict the completeness of the OSM building footprints database in countries with high disaster risk. This included the development of a multivariate model using open source Python libraries that can be deployed using Jupyter Notebooks and Google Earth Engine. The model can be used to identify areas that lack OSM coverage and can help prioritize mapping efforts, especially in vulnerable areas and where current data gaps pose an obstacle to timely and evidence-based disaster risk management. So these are just a few recent examples of the great utility and versatility of open source software and how it's being used by different organizations to deliver innovative solutions for a range of use cases and missions. Open source software is vital to the development of the national spatial data infrastructure and a plethora of responsive web applications, open science models, data processing platforms, distributed high-performance computing architectures, and much more. And the growth of the open source ecosystem offers more technology and design alternatives and opportunities for the geospatial community to uncover and deliver insights to solve today's global challenges. Thank you.